Ever stop to think about what's really going on inside the tech you use every single day? Your phone, your car, even advanced medical gear. Well, they're all powered by tiny, invisible armies of microscopic machines. And no, that's not science fiction. It's the hidden world of MEMS. And today, we're going to pull back the curtain on this incredible technology that, quite literally, runs your world.
Seriously, let's just dive right in. Every single time you tilt your phone and the screen magically rotates, or when a car's airbag deploys in the blink of an eye, you're seeing MEMS in action. All of this is powered by components so ridiculously small you can't see them with your own eyes.
And you know, when I say small, I mean really small. Just look at this. That tiny little speck next to the dime, that is a complete, fully functional pressure sensor. Some of these things are smaller than a single grain of rice, but their impact on our lives is absolutely huge. It's just an amazing feat of engineering.
So, here's our game plan for today. We're going to start by exploring this microworld and what these things actually are. Then, we'll look at their anatomy and figure out how they're even built. After that, we'll go on a hunt to see where this tech is hiding in plain sight, and finally, we'll take a little peek into the future.
All right, first up, let's jump into the micro world. We're about to decode technology that is, and this is not an exaggeration, smaller than a single human hair.
So what exactly is MEMS? Well, the official name is Micro-Electromechanical Systems, but what does that mean? Simply put, it's a technology that smashes together the brains of a computer with tiny little moving parts, things like sensors, gears, and valves, and puts it all onto one single chip.
You know, the name itself actually tells you the whole story. Micro, obviously, we're talking about its unbelievably small size. Electro, that tells us it's all about electricity and electronics. Mechanical, this is the cool part. It means there are actual, physical, moving parts. And system is the key that ties it all together. It's not just one gadget, it's a whole integrated system on one little chip.
To really, truly get a feel for that micro scale, think about this. The tiny features on a MEMS device are often less than 100 micrometers wide. That is about the same thickness as a single strand of your hair. We're not just making things a bit smaller here. We are operating on a completely different level. Okay, so now let's get into the anatomy of a MEMS device. And honestly, the best way to think about it is that each one has its own senses, its own brain, and its own muscles, all packed onto one chip. So yeah, every complete MEMS device really boils down to three key functions. And just like we said, you can think of them as senses, a brain, and muscles. Let's start with the senses. First, you've got the senses. These are the microsensors. You can think of them like the eyes, ears, and nose of the device. They are constantly collecting data about the world around them, detecting stuff like motion, changes in pressure, heat, or even certain chemicals.
All that information then gets sent straight to the brain, and that's the microelectronics. This is the processor. It takes in all that data from the senses, crunches the numbers, and decides what needs to happen next. It's the central command center making all the calls.
And finally, that brings us to the muscles, or the microactuators. These guys get their orders from the brain and then they do something. They create a physical action. It could be something like flipping a microscopic switch, moving a tiny mirror, or spinning a miniature motor. So it's sense, think, and act, all happening on a scale smaller than a hair. So, we know what they are. We know what the parts do. But how on earth do you actually build something so incredibly complex and so tiny? Well, that brings us right to our next section, the amazing art of microfabrication. Okay, so when you get down to it, there are two main ways to approach this. First, you have bulk micromachining. You can think of this as being a microscopic sculptor. You start with a solid block of silicon, and you chemically carve or etch away material to create your final shape. Then there's surface micromachining. This is a lot more like 3D printing. You build the device layer by painstaking layer right on top of the silicon wafer. Now, one of the most mind-blowing techniques out there is called the LIGA process, and it's perfect for building tall, really detailed structures. First, use powerful X-rays in a process called lithography to basically blast a deep mold. Next up is galvanoforming, where you electroplate metal into that mold, creating a perfect metal copy. And finally, you can use that new metal part for molding as a master key to mass-produce tons of these components. And would you look at the result? That is not a computer drawing. That is a real, working micromotor, built with the LIGA process, complete with those tiny interlocking gears. The level of complexity they can achieve at this scale is just mind-boggling.
This technology is absolutely amazing, but it's not just some cool thing stuck in a research lab. So where do we actually find it? That brings us to our next part, where we'll see how MEMS are secretly all around us, invisibly powering our modern lives.
So where are they? Well, the short answer is pretty much everywhere. That tire pressure sensor in your car? That's MEMS. The accelerometer and gyroscope that know when you tilt your phone? Yep, MEMS. Even the tiny nozzles in an inkjet printer firing off perfect droplets of ink? That's a type of MEMS. The list just goes on and on.
But one of the most critical applications right now is in what we call RF MEMS, for radio frequency. These are highly specialized little machines that are designed to physically switch and control the signals our wireless communication completely depends on.
And this right here is why RF MEMS are a total game changer for things like 5G and the 6G networks on the horizon. I mean, compared to the old way of doing things, they use next to no power, they give you a super clean signal with way less interference, and they just work beautifully at the super high frequencies that these new networks need to run. So, we've had a good look at the incredible world of the micro. But you know how technology is, it never ever stands still. Which leads us to our final question, what could possibly lie beyond micro? Well, let's talk about the nanoscale frontier. The next great leap is NEMS, that's nano-electromechanical systems. And as you can see, we're taking miniaturization to a whole new level. While MEMS is at the micrometer scale, the width of a hair, NEMS devices are built at the nanometer scale. That's 1,000 times smaller. And it's so small, it forces a change from that top-down carving method to a bottom-up approach, where you're basically building machines atom by atom. You know, when you look at this whole journey, from computers that filled a room to the MEMS that fit in our pockets, a really clear pattern emerges. It seems like the smaller the technology gets, the bigger the revolution it creates. Every step down in size just unlocks so much more power and potential. Which really leaves us with one last kind of mind-bending question to think about. We've gone from micro down to nano, building real machines on a scale that's almost impossible to comprehend. So as this technology keeps getting smaller and smaller, what giant possibilities will it unlock next?